Life is a complex beast. Because of symbolism and language, it can be as complex or simple as you want it to be. Life itself doesn't care how you simplify and symbolize it. It remains complex in itself. But repeatability and continuity can be fairly identified and symbolized. Language and symbols sort of fail to quantify a qualitative. That's why it has an artistic feel to it. The substance of reality is fundamentally different than the descriptions language can produce. But for all intents and purposes, our symbol systems and rules helped us manipulate reality to create cars, phones, houses, medicine, computers. So while our symbols can't even come close to capturing reality as it is, they describe enough of it to be a useful tool to elevate humans to a level to, at a minimum, stand toe-to-toe with nature and become the top of the food chain. Computers have captured and augmented our representations of reality and allowed us to continually change our models of the world. That which stays the same can persist, and that which gains conditions can shift probabilities. Artificial intelligence will take that one step further. Not much is absolute anymore, but that doesn't mean nothing can be known. What it means is that if you want to understand, you have to allow conditional possibilities. If it makes you uncomfortable because absolutes are easily resolved, you're relaxing into oblivion. Understanding takes maintenance, but what is lost by avoiding it is incalculable. Enumerative induction is a form of reasoning in which general conclusions are drawn from specific observations. In this process, one observes individual instances or cases and then formulates a general rule or principle that applies to all cases of that kind. It's often referred to as simple induction or simple predictive induction. It moves from the particular to the general. For example, if you observe that the first swan you see is white, the second swan you see is white, the third swan you see is white, you might conclude by enumerative induction that all swans are white. This type of reasoning is common in science and everyday reasoning, though it has limitations. One issue with enumerative induction is that it can lead to incorrect conclusions if the sample of observations is not representative of the whole. For example, encountering a black swan would refute the general conclusion that all swans are white. While enumerative induction is a common and useful form of reasoning, it has limitations, no guarantees. Even if we've observed many instances, there's no guarantee that the pattern will continue to hold. A single counterexample can invalidate the generalization. Limited scope. Enumerative induction is often limited to generalizations about observable properties. It's less effective for making predictions about unobservable phenomena or future events. Susceptible to bias. Our observations can be influenced by biases, leading to faulty generalizations. Despite these limitations, enumerative induction is a fundamental tool in scientific inquiry and everyday life. It helps us make predictions, understand the world around us, and develop theories. I wanted to cover the fallacy of composition because while we have to be careful with induction to understand that our general conclusions are subject to revision, some just want to jump to absolute negation of anything that has any kind of exception. A case supported inductively that does seem to be the case for 99% of particular instances is not completely invalidated the second a single exception is found. Now we just say the case is true for 99% of observed instances. I don't know what to say about it except that some let the perfect be the enemy of the good. And they unknowingly choose existential crisis when if they just stopped insisting that reality be perfect for their standard, they could then know the 99% that can be understood. Let's talk about the fallacy of composition. The fallacy that describes dismissing a general rule based on a single exception is called the fallacy of composition. In this case, someone might take a specific exception or unusual case and use it to dismiss or reject a general principle or rule that applies to the broader group. The fallacy of composition occurs when one assumes that what is true for a part, the exception, must also be true for the whole, the general rule. For example, the one person who didn't finish college became a billionaire, so college degrees aren't necessary for success. This reasoning dismisses the value of a college degree based on a single or rare exception, ignoring the general trend that higher education typically leads to better job prospects and success. So we have to be cautious about inductive reasoning. Use probabilities. When we generalize about a case, we're not insisting that everything is absolutely perfect for all time. We're just putting out an intellectual structure that can grow and change as information changes. We can reason with changeable conditions of truth and review the effects of working with conditional hypotheses. So final message, be careful with induction and don't fall prey to the fallacy of composition. If you like this kind of philosophical subject matter, help us out by liking the video and subscribing to the channel.